In this video, we're going to look at another application of right triangles, and that's involving bearings. So we're going to look at two different methods for measuring bearings. And a bearing is a way of giving direction to some object, some moving object. So the first method is when you are given just a single angle as a bearing, it's understood that the bearing is measured in a clockwise direction from due north. So this is our first method for a bearing. So this image illustrates bearings of 32 degrees, 164 degrees, 229 degrees, and 304 degrees. All of them starting from due north, or I kind of oftentimes think about it as that positive y-axis, and then moving in a clockwise direction to that angle measure. Find the bearing of an airplane located at -5, if a radar station is located at 0, 0. So they're giving us some angle coordinates. So we're going to set up a normal XY coordinate grid. We know that our radar is at 0, 0. We're going to label that with an R. And the airplane is located at -5, 5. So that's going to be in our second quadrant. Right here, our airplane's right here. So what we're really looking for when we're trying to find the bearing is the measure of this angle here. So to find this angle, we're going to start working with this triangle, and I'm going to end up pulling this triangle off that grid just to illustrate it. But we're working with this triangle right here, this right triangle. So I'm going to redraw that because a lot of times with these, it is easier if we redraw. And if I can find this angle theta, then I can find that bearing. Now, pulling this triangle off of that coordinate grid, we get just these magnitudes of those lengths, 5 and 5. So to find theta, we're going to use tangent of this theta, and I'm going to use green just to keep this consistent with our picture and know that that's not actually my answer. It's not my bearing, is equal to 5 divided by, oh, and this is actually, we're going to keep it -5 so that we can, no, I'm sorry, we're going to keep it as just +5 for this because we've removed it from that coordinate grid. So that means theta is equal to tangent inverse of 1. And that gives us this angle measure of 45 degrees. So that tells me that this angle right here is 45 degrees. And if I put that back in the original picture, that means that this angle is 45 degrees. Well, that's not my entire bearing. My entire bearing starts at that due north, that true north, and goes all the way around. So the bearing is going to be, thinking again, starting from here, there's 90, 180, there's 270, plus that 45 we just calculated. So our bearing is 315, or the bearing of the airplane is 315 degrees. Two ships leave port at the same time. Ship A is traveling on a bearing of 40 degrees at 18 miles per hour. Ship B is traveling on a bearing of 130 degrees at 26 miles per hour. How far apart are the ships after 1.5 hours? A quick note down here, ship speeds, watercraft speeds are traditionally measured in knots or nautical miles per hour, which are not exactly the same as miles per hour. It's approximately 1.15 miles per hour. So for simplicity, we're just going to measure their speed in miles per hour, but just note that this application has been simplified just for the sake that we are not all familiar with nautical miles. All right, so we have two ships leaving port at the same time. So we're going to start by identifying where our port is. So I'm just going to make a point and label it P. Now I'm going to draw this auxiliary compass just so that I have some landmarks of where I'm going to measure my bearings for. So ship A is traveling on a bearing of 40 degrees. So starting from our due north, that's that, think of it as the positive y-axis, and then going 40 degrees clockwise. So this ship is traveling, say, this way, where this angle is 40 degrees. And I'm not going to terminate this yet, because I might have to extend it further to finish off my picture, but it kind of gives that trajectory. Ship B is traveling on a bearing of 130 degrees at 26 miles per hour. So again, starting from that due north and going 130 degrees, we're going to be somewhere down here. So this is the direction that ship B is traveling, where this angle is 130 degrees. And what we're trying to figure out is how far away are the ships? After 1.5 hours. So here's our unknown, X. So a couple things here. We want to start investigating this picture and see if we can find some additional information, because we are going to be working with this triangle that we've just formed, but we don't really know a whole lot about that triangle. What we do know is that, and I'm going to have to do some highlighting and erasing just so that the picture doesn't get too crowded, that this angle is 40, which means that this angle right here is 50. We know that that pink angle is 130, which tells me that this angle is also 50 degrees because they're supplementary, right? That straight vertical line makes a supplementary angle. And then if I look at this right angle, that tells me that this is 40 degrees. Now it's a little hard to see, but what we have just determined is that the angle formed by these two ships is a right angle because that top was 50 degrees and the bottom was 40 degrees. And let me clear that out so you can maybe see a little bit better. Got a little bit of a lag here. So what I'm gonna do is I'm gonna pull that picture out, that triangle out, but I know that I've proven that this is now a right angle. We're gonna call this ship A and this ship B. Again, here's our port. And this is what we're trying to find. Now, the other information that they're giving us is how fast the ships are traveling. So ship A was traveling 18 miles per hour. Well, if we're traveling for 1.5 hours, this length is going to be 18 times 1.5 or 27 miles. Ship B was traveling at 26 miles per hour. So 26 times 1.5 gives us how far ship B has traveled, and that's going to be 39 miles. And now we can use the Pythagorean theorem to see how far apart these two ships are. 27 squared plus 39 squared equals x squared. 27 squared plus 39 squared is 2,250, which means that the two ships are approximately 47.4 miles apart. You'll see me illustrate pictures in two different ways a lot of times. That first picture, when I'm trying to get all this information down, it gets very crowded. So it gets a little overwhelming, and just, it makes it easier for me to see the picture that I'm actually trying to solve once I've gotten rid of some of the information that I don't really need anymore. I didn't really need that 40-degree bearing. I didn't really need that 130-degree bearing anymore. So you'll see me do this a lot. Another piece of advice is give yourself plenty of space. The smaller you try to draw your picture like this, the more crowded your picture's going to get, and it's going to be harder to read. Now, the second method for measuring bearings starts with either a north or a south line and then uses an acute angle to show the direction either east or west. So these four pictures illustrate bearings of north 42 degrees east, south 31 degrees east. So again, we start in this first one, we're starting from that true north and then going 42 degrees to the east, which is to the right. South 31 degrees east, so starting with that south line and then going 31 degrees to the right again for east. South 40 degrees west, so starting with that south line and then going 40 degrees to the left, which is west. And then north 52 degrees west, again starting with that north and then going 52 degrees to the left. So a similar example, two ships leave port at the same time. Ship A is traveling on a bearing of south 61 degrees 50 minutes east at 24 miles per hour. Ship B is traveling on a bearing of north 28 degrees 10 minutes east at 26 miles per hour. How far apart are they after 4 hours? So we're going to start by setting up the information given with the angles, and then we'll redraw that picture and add side lengths after that. So let's start setting up our picture. Again, two ships are leaving port at the same time, so we're going to start with drawing our port and an auxiliary compass just to help us start drawing some lines. Ship A is traveling on a bearing of south 61 degrees 50 minutes east. Let's go ahead and actually make those conversions. Just so we're dealing with decimal degrees. So 6150 is 61 plus 50 over 60, or about 61.83 degrees. And then 28 degrees 10 minutes is approximately 28.17 degrees. That way we don't have to work with degrees and minutes for this example anymore. So south 61.83 degrees east. So starting with this south line and then moving to the right 61.83 degrees is going to be about here. So we know that this is 61.83 degrees. And then ship B, that's ship A. Ship B is traveling on a bearing of north 28.17 degrees east. So starting with this north line and then going to the right 28.17 degrees. Here's ship B, and here is 28.17 degrees. And again, what we're trying to find here is this value of X. I'm going to go ahead and pull this triangle out so that we can start identifying some other values. But just to point out where we're headed, here's ship B, here is ship A. This is what we're trying to find. Now, similarly, we can start building on what these angles are. Starting with this angle, because it is complementary. Remember that north and east line are going to make a 90-degree angle, so it's complementary. This angle is going to be 90 minus 28.17. Just 61.83 degrees. And likewise, we can find this angle by doing the same thing, taking 90 and minusing 61.83. And you might already see where this is headed, but if not, that's okay. So 90 minus 61.83 is 28.17. And if we were to combine those 2 degrees, 61.83 and 28.17, this is actually 90 degrees. So now we can see that this is a right triangle. Ship A is traveling at 24 miles per hour for 4 hours. So we want to be real careful that we're labeling the right side. So this is going to be 24 times 4, which is 96 miles. Ship A has traveled. And then ship B is traveling 26 miles per hour. Hello. Sorry about that. I just got a call from the vet. So I feel like I'm a little bit distracted and need to refocus myself. I think where we left off in this was looking at now the distances that each ship has traveled. So we know that ship A traveling at 24 miles per hour for 4 hours has traveled 96 miles, and ship B traveling 26 miles per hour for 4 hours has traveled 104 miles. And using the Pythagorean theorem, we can now figure out how far away these two ships are from each other. 104 squared plus 96 squared equals x squared. 104 squared plus 96 squared is 232. And then to take the square root, we find that x is equal to 141.53, which represents the miles that these two ships are away from one another. The bearing from Atlanta to Macon is south 27 degrees east, and the bearing from Macon to Augusta is north 63 degrees east. A car traveling 62 miles per hour needs 1.25 hours to travel from Atlanta to Macon and 1.75 hours to travel from Macon to Augusta. Find the distance from Atlanta to Augusta. So these are 3 cities in the state of Georgia. We're going to start by setting up a bearing from Atlanta to Macon. So I'm going to just mark an arbitrary spot. Atlanta. And I'm going to set up this auxiliary compass. And the bearing from Atlanta to Macon is south 27 degrees east. So I'm going to start with that straight down, that south line, and go 27 degrees to the right. So somewhere over here is the city of Macon. I'm going to extend that. So this is 27 degrees. Then we know that the bearing from Macon to Augusta is north 63 degrees east. So drawing another auxiliary compass, north 63 degrees, starting from that north line and going 63 degrees to the right. So this is 63 degrees, and somewhere over here is Augusta. And what we're trying to figure out is how far away is Atlanta from Augusta? So now we need to start building out this triangle. We know that we're going to be dealing and working with this triangle here. But we need some more information about that. But I am going to pull it out of the graph just so that I have it and I can here's Atlanta, here's Macon, here's Augusta. So looking back at our original figure, I'm going to extend this line down to form this little right triangle in the bottom left-hand corner. If that top angle is 27 degrees, what that will give me is this angle right here. So 90 minus 27 is 63 degrees. And then because we have a right angle here, we can see that that other interior angle for at the city of Macon is going to be 90 minus 63, or another 27 degrees. Now we can use the properties of those angle pairs for parallel lines, but I think this is just as easy. And now we can see that this interior angle, and I'm going to try to use some different colors here to help highlight it, that this angle right here at Macon is 27 plus 63 degrees, which is 90. So here's our right angle. So now we've got our right triangle. We've removed a lot of that extra stuff, but let's add those side lengths. We know that a car traveling 62 miles per hour needs 1.25 hours to travel from Atlanta to Macon, which means that that distance between Atlanta to Macon is 62 times 1.5 hours, which is 93 miles. Oh, sorry, it's 1.25. Sixty-two times 1.25 is 77.5 miles. We know that a car traveling 62 miles per hour needs 1.75 hours to travel from Macon to Augusta. So that distance is going to be 62 times 1.75, which is 108.5 miles. Applying the Pythagorean theorem, 77.5 squared plus 108.5 squared is equal to x squared. 77.5 squared plus 108.5 squared gives us 17,778.5. And we're going to take the square root of that to find the distance between Atlanta and Augusta to be 133.34 miles approximately.